Very good. Let me share my screen. Very good. All right. How's everyone doing this week? Week one's a pretty easy week. There should have been, not a whole lot of hair pulling out. What's this mean? Why can't I get the code to work? What's this weird error? Any questions, comments, or concerns about week one and looking at week two?
I have a question about week 2.
Sure.
So we don't want like redundant data, but is there ever a time where like how do you decide when to make a linked table, or is there ever a time where you're just like, no, I'll just have it in the original table?
It's a good question. So I'll give you a good answer now, and then in 2 weeks when we start designing databases, I'll give you a really, really good answer. Okay. So when we design a table, we want to make sure the data that goes in that table only has to do what's in that table. Okay. So if I create a table called customer, I'll have like name, address, phone number, email address, so on and so forth, right? But if I'm doing a bookstore company, right, I'm not going to put like, say what they bought, things like that. I don't want things that directly relate to that customer in that table. So I got a customer table. Now, when we look at it, there are times we'll look at it and go, do we want the information here? For example, let's say we were in a company that sold t-shirts, right? And our shirts came in many colors. Okay, so we had a table called shirt, and the table was like, size, blah blah blah, and then there's color. And so we put in the color in that table, right? Now let me see. We're gonna do this now, and okay, so let's go over here to my new model. All right, here we go. You're the first class to get me to do this on week 2. There we go. Okay. Okay, so I'm gonna make a table here, and I'm gonna call this shirt. So first of all, let's talk about some table etiquette here, okay? Names of tables are always singular. They're never plural. So it's not shirts, it's shirt. It's not customers, it's customer. I don't know why it's just the way it is. If you want to be rebel, go and make them plural. Everyone look at you funny, but that's cool sometimes, So my table is shirt, and the table always starts with an ID. So it always got shirt ID, and we're going to say that's int, but in 3 weeks, we're going to talk about differently why we might not use int. And I'm going to put here, I'm going to do size, okay? And I'm going to do UPC, right? And then I'll put color. So now I have the color of the shirt. Now, when I'm inserting data in the table, I put, 1 large, blah, 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 blue, going on and so forth, right? So I'm putting the information in that table. So we keep that information here. Let's say when we talk about normalization of data, we do it for a couple different reasons. And one of the reasons we do is because, and this is not a nice thing to say, we don't trust our end users to do things right. We just assume that our end users are going to make a mistake. And it's not a mean thing to say, it's just true, because someone had a bad day and someone forgot how to misspell red, right? So we have, Timmy, who works in data entry, and his job is to input all the new shirts. And there were 12 new red shirts, and he misspelled 2 of them. One is ERD and one is DRE, right? So now we have 2 new colors in our lineup because Timmy couldn't spell. So what we do to protect ourselves from that is we'll create a new table, and we'll call that table color. Okay. And we'll have a color ID, and then we'll have color. Okay. And what we're going to do is we're going to get rid of the color column over here. Delete. All right. And then we're going to do what's called a one-to-many join. That means one column in here will reference many columns in here. Everyone follow me? This is like week 5 or 6 stuff. So if anyone goes off the rails, just get some popcorn, sit back. We'll cover this again in 3 weeks. Okay. So over here on my toolbar, I've got these 1-to-1. This is a 1-to-1. This is a 1-to-many. This, I don't know. I honestly don't know what the difference the dotted line and the single line is. So just use either. I'm not sure why they have this, both of them. Maybe aesthetics. So there's a 1-to-1 relationship and a 1-to-many relationship. 1-to-1 means one instance here matches up with one instance here. So there will only be one color. That's not the case. 1-to-many, one color will be on many shirts. That's what we want. Many-to-many, and the cool thing about this, so many-to-many relationships are evil and forbidden. Okay, because that will cause a whole mess, because one shirt will have many colors and many colors will be on one shirt. You know, that's very, very confusing to be only in 2 tables. And so we'll talk about that in a second with that, what changes there. Okay. So, so I want to do 1-to-many. So I'm going to do here, and I think this is the direction to do it. That was incorrect. Let me do this again. I'm going to do 1-to-many. So now my color here ties into here. Okay. So this creates something called a foreign key. So what happens here is with a foreign key, if it's not in this table, I can't put it here. Okay. So if I just get an inventory of chartreuse shirts and I try to input them, chartreuse isn't a color here. I got to add it, right? So I can't do it here. Also, I can't delete from this table without deleting from here first. So I can't delete a color because I've got all these shirts that got colors in them, right? So foreign keys protect our data. So that's one way of normalization. But the reason why we do this here is because we got to assume that we're going to have a front end that the data is going to be put on, right? So we want to make sure we've got consistency in our data. And the best way to make sure we have consistency in data is don't let people try and spell things. Because if people try to spell things, we'll have inconsistent data, because I don't know how to spell chartreuse. I don't know if you do. Red I can spell. I'm good with rel. Turquoise I'm a little off on, right? But so this way it keeps it. So when we talk about normalization of data, this is part of it. Keeping the data clean, right? Other times we want to put, so let's say, let's take this in a different direction. Okay, so oops, oh, I don't want to do that. Thank you. I just want to get rid of the color thing here. Okay. So get rid of this. Okay. So let's take size out of here. Okay. I'll go here and take rid of size. And let's make a size table. Okay, thank you. Size ID. And then just size, right? So, right, okay, give me what I want here. Okay. Thank you. Okay, so there's that. So now with insert here, we just have UPC, and then I've got a color table. So one UPC will come in many sizes, and one size will come in many different UPCs, right? So we want a many-to-many table. Now the cool thing is, I said that they're vile and things of Satan. So when you do here, when you make a many-to-many, it creates a middle table there. Okay, so now you'll see what we have is we have a 1-to-many here and a 1-to-many here. So now this is where we have here, we've got the shirt size and the shirt ID. So the shirt ID and the size ID, and then we can add quantity and stuff like that. Okay, this is just another way to normalize the data. Am I making sense here? Is everyone with me? This, if it's over your head, that's totally fine. This is week 2. Like I said, this is like weeks 5, 6 stuff, right? But when we're figuring out what's in a table, let's take a look at this. I was going to show you guys how to do this anyway, so let's look at this now. Let me get this here. Okay, so there's this cool little feature here called reverse engineering. So what I just designed there was this little ERD. Okay, it's ERD stands for entity relationship diagram. It shows how the tables talk to each other and how the data flows, right? So if I go here to server databases, I have this thing called reverse engineer. Okay, brings up this little wizard, and I'm going to say I want to connect to my DBMS, all this other stuff. Yes, thank you. I want to reverse engineer Sakilla. Thank you so much. I want to get all the objects. Thank you. And then put all these objects in a wonderful diagram for me. And I want to see that diagram. And here is the ERD for the Sakilla database. Okay. That should not be there. Well, that's for this table has something to do with an exercise question in week 11. It is one of the dumbest questions that we deal with because it makes you do coding things that no normal human being would ever do. So there's that. One of these days, like one of the designers is going to watch my videos and I'm going to get in so much trouble, but that's okay. I don't mind. So like here in film, right? Let's look at the film table. In the film table, we have everything here has to deal with what the film is. Film ID, title, description, release year, language, original language, rental duration, rental date, length, replacement cost, rating, special features, last time was updated. We wouldn't add a column in here like actor, right? Because one film has many actors. And we wouldn't put that in the film table. We wouldn't put in here like filming location. We wouldn't put in here director and things like that because they don't tie directly to the film. They find, it might seem odd to say that the director and actor kind of are tertiary information to the film, but they are because they got to be in different tables. Okay. So that was a long answer to a short question. Does that answer your question, Emery? Okay. Did it over answer your question? It's okay. Yes, I did way over answered your question. But I wanted to show you guys this tool here, the ability to reverse engineer a database. It exists in every existing database platform. You can reverse engineer database from the database into an ERD. And it's something you may want to do because the best way to understand how data flows is to, believe it or not, look at this, even though it looks like a really bad traffic diagram. You can see where all your foreign keys are. You can say, okay, this foreign key is over to here. Category, foreign keys to person, film foreign keys to film actor, and so on and so forth, right? We'll talk more about ERDs later, but this is just kind of a fun tool. Also, and this is foreshadowing, if you look at our database, now I've got something called forward engineering. So those of you who are thinking that maybe I want to do the project, when you create the ERD in here, right? And I tell you, one of the things you've got to submit to me is the code to create the database. If you go to database and forward engineer, guess what it does? It makes the code for you. Generate all the objects, and there's the code to create everything. If MySQL does this, imagine what Microsoft SQL Server or Oracle does, right? But anyway, I digress. Okay, that was a fun tangent. But like I said, we'll cover this way more. We will we will probably create in this class 2 or 3 databases just on the fly on the weekly meetings, just to give you guys the feel of how these things get made and understand the flow of data, how data flows, and how when you start with one table, you end up with like 16 by the time you're done. You're not sure how you got there. Because like I said, when I used to do this in person, I used to have all the walls in the room for dry erase boards, and I'd start in one corner and work all the way around. And by the time the class was done on day two, I had a database that covered everything. And people dropping out of the class because they got confused. But I'm just kidding about that part. No one dropped. There were small classes, 8 people. It was all certification classes. Anyway. All right. So what do you have to do this week? So reading and preparation and reading. we got here, learn mechanics SQL. We're going to talk about it. We're going to talk about SQL clauses. We're going to talk about all this stuff today. I'm going to show you some examples of code. We're going to have some fun. Now, so the way I work, when I talk about code, I will talk about things that are not on this week's lesson. They're on lessons 3 or 4 weeks down the road, but it makes sense to talk about them here. Okay, so we'll start the conversation here about different things like concatenations and aggregates and stuff like that. And then like when week 4 or 5 rolls around, you're like, oh, I remember that from week 2. But the questions you're going to have on your exam and your exercises are going to be way simpler than what the code I'm going to show you tonight. But it's a lot. It helps me to logically explain to you how this works by giving you these little bells and whistles. And there are some things I'm going to show you that are never mentioned in the course anywhere. They're just so you know them. You've got the video on how to reverse engineer our website. You've got the video on the basic relation model of a database. Watch these videos. They're not nearly as cool as mine, but that's okay. Not all of them can be, right? How to write basic queries. All this stuff is you don't have to watch them all, but just kind of get an idea of this. Particularly, I would definitely watch this one because you have to do this this week. How to reverse engineer a website. Again, remember, choose a simple one. Bob, feel free to do Family Search for you worked for them. But anyone else who didn't work for Family Search, choose a. You have no idea how many semesters I would say don't choose Family Search, and you walk into my classroom and you worked for them, right? It's just funny. It had to happen eventually. Choose something simple, and again, like I said, just pull up the website. Tell me how you think the database works. I don't. This really is just so I can say I've got a video of the student performing a task for a grade. Please don't make us use Proctorio this year. That's what this comes down to. All right. There's that. We're gonna talk about that. So, okay, so there's that. So we got that done. Okay. So just the reading and stuff. You got your quiz. Let's see. There is. Oh, was it this week? I can't. I think in week 2 there's a question on the quiz. Does MySQL look like this when you start it up? Just answer true. The answer is true. It is the old version of MySQL and it doesn't look the same anymore. So if you say false, it's going to be wrong. And I'll have to go fix it. Save my time. Just say true. You may not get it because there's like 60 questions in the pool and you only get 10 of them. So if you're lucky, you get a free question. Got the quiz and the reverse engineering website. All right. Okay. And the exercises. Let's look at the exercises. Shall we? Let's see what you're looking at. Let's see. The answer's right here. So you say write a SQL statement that retrieves the first name. Okay. So yes, you'll be required to write code. Write SQL statement that retrieves data. Okay, there you go. Write a query that against the rental table that returns the ID of the customers who rented a film on July 5th, 2005. Okay. All right. All right. So only 5 questions. You guys got this. By the time we're done here tonight, you'll know how to do this. Don't worry about it. All right. So that's good. So let us look at some code.
Brother Stevie,
Hit me.
just one thing I noticed in the exercise or the quiz after I started it, because it says that you can work in groups, but each student must submit their own quiz. But I'd already opened this.
So about that, I am all about community effort in this class. If you are having trouble writing a query, I don't know who uses the discussion boards anymore. Like the first 3 weeks they're used and then they're just like a ghost town. But I did put you in groups. So everyone is in a group. So if you're having trouble writing a query, reach out to your group. Reach out to me. I will help you. I'll give you the information you need. Sometimes I'll just give you the query you're looking for. Depends on where I am in the day. But absolutely reach out to other people for help. So yeah, so if like 3 of y'all, Zoom together one day and work through all the exercise yourself, awesome, right? So, but yeah, you can absolutely work in groups. Because I mean, here's again on a soapbox again. when you're a DBA and you're working in field, you're working in a pen of like 3 or 4 DBAs. And if you're having trouble with code, you reach out to other people and ask for help, right? So I'm totally fine with this class mimicking real world, right? So yeah, anyway, I'm off my soapbox now. So yes, feel free to work with each other. I'm totally fine with that. I think that's great, actually. Okay. So there's that. Okay, so let's talk about some code. Like I said, so if you're like me, you're gonna forget to do this every time. Whenever you open when you open up MySQL and you got this wonderful thing here in front of you and you're writing your code, make sure you use the word use Sakilla first and run that, because if not, you're gonna get all sorts of errors. So other thing here is if you run highlight and just run that little piece, it just runs the one piece that's highlighted. So you can troubleshoot that code that way, okay? So our first query is something very simple. We're gonna select the first name and the last name from customer. That was exciting. But here's the thing, like I said, this is English. Select the columns from the table. This is not difficult to understand. This isn't like get A equals 46/site, like what you do in VB.NET or whatever, or in C#. This is just like, go get this. It's like telling your kid to get the remote so you can change the channel. Again, select last name from first name. Boom, there it is, right? So here, let's get a little fun. Here's a command called concat. Concat means combine. Concat is used to combine string values. Okay, there's two words. There's concatenation. There's aggregation. Concatenation has to do with string values. Aggregation has to do with numeric values. So I have select concat last name, comma, single quote. Only use single quote, comma, single quote, first name as customer, from customer. I'm gonna get rid of this as customer for a second here. From customer, order by last name. So here I got 2 additional commands. I've got concat, so I'm telling it I want this information returned in one row with a comma between the columns, and I want you to put an order by last name. Someone got a question? Someone went live. Nope. All right. So let me run this. So here I've got, here's everything, order by last name, first name, and then I've got this bizarre column name. Okay. Whenever we concatenate or aggregate columns in the select statement, the name of that column is whatever it took to get there. So that is the name of the column. That is not helpful. No one but you will understand what that is. So you've got this little alias. So we can say, show this as customer. And when we run this again, now people know, oh, that's the customer. What was concat? I didn't understand what concat meant, right? Let's do it here again, and let's add store ID to it. Okay, same thing, store ID. I'm gonna go back here, and I'm gonna order this by store ID. Nope, that's not. I was order this by store ID. That's what I do. Okay. So it's still ordered it, but store ID isn't there. So the order by command, which it tells you how to sort the output, that column doesn't have to be in the select statement. It can be whatever column you want to sort by. Okay, so it doesn't have to be there. So we got this, we got select, we got concatenate, we got order by. So here, let me do this order by store ID. So there we got everything's ordered by store ID. There's 2 stores, 1 and 2. Get down there too. Okay. Now I'm going to order by store ID and then by last name. So if you look at here in store ID, I got in this one I got Smith, Johnson, Williams, Brown. If I do this, I now have Abney, Adam, Alexander. So I'm ordering by the store ID first, and then I'm ordering by the the last name alphabetically. I can also go here and add these 4 letters, descending, which means do it backwards. Okay, so now it goes backwards. So there's 2. By default, ascending is there, so you never have to put ascending unless you want to. By default, it does that, but descending brings it backwards. So notice I'm doing store ID ascending and last name descending because it's still 1 and 2. So you can play with that, okay? Everyone with me so far? Have I lost anybody? All right, let me scroll down the pictures here. I have not Erwin, Tally, Moynihan, Raphael, and Cade. You guys doing good? All right,
Yeah,
silence.
I'm good.
Excellent.
Professor.
Excellent, excellent. All right, so let's add another clause. Let's add the where clause. The where clause says filter. Don't show me only this stuff. So here I've got selecting store ID, concatenating last name and first name from the customer table where last name is like D. So you still a D and percent sign. So I should never do this one first. I should do where. So let's do this. Hang on. Let's do this the right way. I'm sorry. Okay. So we're doing the store ID, concatenate last name, first name from customer, where last name equals Young, ordering by store ID and last name. So just Cynthia Young, she's the only one. Okay. So what this does, it looks for that exact string and returns the values with that exact string. Here, I'm going to say where last name like D%. So what this does, so sometimes when you're doing a search, you want to find like, you know, just the name that starts with a specific letter. I got all these chats. I'm sorry. Let's see anything here. Yeah, Control Enter runs the code where you're typing. Yes, okay, that's things we're going now. Okay, nope. Oh, okay, so this is kind of like where old habits die hard for me. In Microsoft SQL Server, if you hit F5, it runs it. So I always try to hit F5 and it doesn't work in this. So I just hit the lightning bolt. There's tons of ways to do this. So whatever works best for you. So where was I? But here. So here, if I use the like command, it allows me to put a variable in there essentially. So here, show me all the last names that start with D. Okay. And we're not ordering by anything. So they're actually, so you'll see the default, it's interesting. The default order by is by last name. So I took out the order by. Okay. Do I get fancy here? I get fancy down here. Okay. So here I've got order by 1 and 2. So there's a question on your quiz this week or next week asking, and you'll see this. And logically, it's if you think about it, you figure out what it is. If you don't know what it is offhand, when I explain to you, you will. When you do order by 1 and 2, this is 1, this is 2. It means you're ordering by the cardinal placement of the columns in the select query. If you do this, you started coding in the late 50s. But that's just one way to do it. I don't know why people doing this just is confusing to people, because if you had 5 columns, you could do this 1 and 4. But yeah, so this is another way to do order by. And I put this here not to encourage you to do this, but because you're gonna have questions on your quiz that reflect this way of writing the query. So if I run this, it does the same thing. It orders by store ID, and then it runs by last name. So here we got that again, right? Okay. Okay, do I do okay, do that here. Okay, so moving on. Adding a different command, and I here. So here I've got count. Okay, count is an aggregate function, meaning I'm combining a lot of numbers in a mathematical function. I'm going to say this 1,000 times between now and week 5. Whenever you use an aggregate in your select query, you must use the group by statement. If you do not use the group by statement, it will not know how to count your aggregate. So here, what I'm asking, there's a column called rating and film. And what I want to do is I want to find out how many of each rating exists in the film table. So if I look at the film table, okay, that is not what, there's one. Okay, here I've got, where's my rating? It's over here somewhere. There we are. I got PG, G, NC 17, G, so on and so forth, right? So I want to know how many R-rated movies there are, how many PG movies there are, how many G-rated movies there are. So what I'm going to do is I'm going to write this query. I'm going to say select rating and select the count from film. And I'm grouping it by rating, meaning this is going to be the column, and then it's going to count everything that, so you're going to count everything that matches that rating. So it's going to how many G movies, how many PG, NC 17, PG 13, and so forth, right? Any column that is not part of an aggregate function must be in the group by. I'll say it again. Any column that is not part of the aggregate function must be in the group by. Count tells me how many things are. So if I run this, I get 178 G-rated movies, 194 PG, 223, so on and so forth, okay? If I take out the group by and run this, I just have 1,000 PG movies because it just aggregates off the first one. It says you're grouping by, I don't have a group by function. I'm just going to take the first one and give you all the rows. So group by, okay. Again here, average. Give me the average length. Here's the rating. Here's the average length. I want to do the average length in minutes of all the films based on the rating. So what's the average length of a G-rated movie? What's the average length of a PG-rated movie? If I run that, I get 111 minutes, 112 minutes, you know, okay. If I take this out again, it's PG, and it gives the aggregate of everything, every movie. Okay. Not in the aggregate, in the group by. In the aggregate, it's fine on its own. Same thing here. Give me the name, give me the rating. So we're doing languages now. So I'm okay. So these are inner joins. Remember how I said I was going to start talking about stuff now that is not until like week 5 or 6? Here you go. Because this is the only way to explain this. So basically what I'm doing here, so I've got the from film, right? So I'm just telling you where to get it from. Here I'm saying I'm going to get information from film and from the language table. So I'm getting from 2 tables, and I want you to connect those tables on the language ID, that column that's in both of them. Okay, so when I join 2 tables, I say get this table, and join on this column. So I'm gonna get the name, the rating, and the count of how many ratings. So the language, the rating for that language, and how many movies fall in that range. From film, joining language, on language ID, and I'm grouping by language and rating because those are not in the aggregate. And then I'm ordering by rating and then name of language. And that's my result. So I've got 112G, 39P, 39 Italian G, and 27 Japanese G rated movies. Does that query make sense to everybody? Is it, is it, yeah? Does it, are you kind of seeing how the flow goes at this point in time? If you don't get the joins, that's totally fine. But do you see how the data is flowing? How I'm going, I've got this column and this column I want individually listed, and this one I want to aggregate.
Could you explain because I understand order by.
Mhm.
Could you explain group by just
Okay.
one
So-
more time? Sorry.
So, okay, sure. So whenever I'm using an aggregate function, which is what it is, count, average, max, min, there's like 12 aggregate functions, okay? Whenever I'm performing a mathematical function in the select query, any column that is not in that aggregate function has to be delineated in a group by, because that tells the query how to count the aggregate. Okay, so here I'm saying I want the count of the ratings. Okay, but I want the count of the ratings, and I just want to know by the rating. So here you go. I have 178 G rated movies, right? I've got 194 PG. So here, this is my aggregate. Give me the count of everything in the film table, but base it off the rating. You with me?
Okay, so yeah, so essentially if you're like, oh, I have something that counts, right? So I need to group by the rating in this case because it's not part of the
Correct.
count. Okay.
Right. So when we look at this one, I'm grouping by, I'm getting the count of the ratings, right? How many movies have a specific rating? But in this case, I wanted to grouped by the name of the language and the rating. So there's two qualifiers for that aggregate. So you're not only going to count how many movies have a rating, you're going to count how many movies have a language and a rating, and then give me that. So if I ran, let me take this away for a second. If I run these at the same time, okay, here I've got G, PG, so on and so forth. But the next one I had G112, G39, and G27, which, by the way, total up to 178. So these, I divided the aggregate more. Before it's just by rating. Now I'm saying do by rating and by language. Okay. So when you start using aggregates in your queries, anything that doesn't have an aggregate in front of it has to be part of the group by, or it's not going to work right. Okay. And just here's another aggregate. Here's max and min. So here I've got rating. Then I've got the maximum replacement for that rating, the minimum replacement for the rating. I run my select query. Same thing, okay. The other thing I want to touch on here before I get into how a query works is I want to dissect the where clause. Is everyone good with the group by, order by? Any other questions on that before I move on? Again, that is not part of your quiz this week. This is future information. We will go over this again multiple times. This is just kind of to get your brain stirring on how this stuff works. Hopefully I haven't muddied the waters for anybody. And if I have, hopefully I can get you back out of the muddied waters. Emery, I may have muddied you a little bit. It looks like you're a little muddy, but it's okay. It's okay. You're going to feel so smart when you go to the exercise this week. You're going to go, well, I can do this. I don't see an aggregate anywhere. It's just a select statement. You want me to do what? I got this. So here, let me dissect the where clause for a second. So I've got select title and description from film, and I've got where description like, and here I just have percent, DOCU percent. So this is show me anywhere where the description column has these these 4 letters anywhere in the word. Okay. And then I have an and clause here. And I'm saying and description is like cow. So I want the word cow anywhere in that description. So this where clause is going to look for anything description that has this and that in it. Make sense? So if I run this, I get 8 results. Some of these bizarre, I would watch this movie. A touching documentary of a mad cow and explorer who must confront a butler in a Manhattan penthouse. I would watch this movie. It is true. I think someone should make this movie. A lackluster documentary of a mad cow and a madman who must sink a moose in the Gulf of Mexico. These are money, man. I don't know. If I go here and change this word to or, it changes what's that. So now it can be this or this. So it can have docu or it can have cow. So this, we had 8 results, and now we have 167. Because this one is documentary, but no sign of a cow. A fanciful documentary of a frisbee and a lumberjack who must chase a monkey in a shark tank. All right. I'm not going to say anything.
You got a question.
Sure.
Yeah. In the last query you run, you have select title and then description.
Yep.
The description is colored blue.
Right. Okay. Good question. Yep. So why is this color blue?
Yeah, it's kind of confusing but not in that line. I can understand it's like a column name, but in the third line they say where description like, then it looks like just a sentence. Or
right. So this is bad coding on the developer's part for this, because description is also a command in MySQL. Okay. So you see anything that's blue is a command of some kind. Like it's a keyword, right? Description is actually a keyword in MySQL. And whoever did this was naughty and shouldn't have used that, because it confuses people because it turns blue. But yeah, all that means is that it's a column name that is also a command in MySQL. That's why it's blue. So yeah, that's an excellent catch and a good question to ask for explanation. In a lot of cases, so and here's a deeper cut on this. If you were in Oracle or MySQL, if you did this, you would get an error because it would only see that as a command. So what you'd have to do is this. Now you see it errors out. See a little red squiggle there? That means MySQL is like, what you doing? Okay. So MySQL, that doesn't work. But in Microsoft SQL Server, if you're using a command name as a column name, you need to put those brackets around it or it won't work. Okay. So did that answer your question, Davis? No, didn't answer.
Thanks.
It did answer your question? Okay,
Yeah,
I thought you said, okay.
Totally. Thank you. Yeah.
Okay. Good. Okay. So here, when you do where, and this whole thing gets fancier. We'll talk about that next week, how much more fancy that can get. But here right now you just need the or and. And says show me everything where both criteria are met, or shows me where one or the other are met. So I can even do this here. Let me take this one here. Let's make this fancier. Or rating equals G. Now I don't know if this is getting any results because I've never run this query before, But here I've got, show me from title and description from film where description is like docu and rating equals G. Okay, so return 256 rows. If I did and, $23 rows. Okay, so you can, and you could go on for a while and make a bunch of different criteria in one where statement. I don't recommend that because that it gets silly after a point. But do you kind of understand how the where clause can get really granular and pull out exactly what you want? One last trick with the where clause. We've said like, we've said equal, and now we can do in. When you use the in clause in a where statement, you've got to give it criteria what to look for. So here I said where rating is in G or PG. So as long as one of the two of those, it'll show up. Okay. So if I run this now, we had 23 rows returned, and now we're going to have 46 rows returned. So now it's going to say, so let's just for fun, let's add rating to this and rerun this. So now it's going to show me all the PG rated movies that also have the phrase docu somewhere in it. Okay. We doing good?
I'm good.
Okay. One last trick, and then we're done with this. I'm going to add a word. Not. So it's going to show me everything that's not here. Give me everything that's not G or PG. So when I run this, it shows me everything else. And if I do this, it's going to show me a lot of, oh, not there. If I do that here, it's going to show me a lot of something else. 573 rows. An action-packed tale of a man and a lumberjack who must reach a feminist in ancient China. It's like AI wrote these. Someone got ChatGPT to write a bunch of descriptions for movies. An emotional drama of a shark and a database administrator who must vanquish a pioneer in Soviet Georgia. Wow.
Reminds me of those old Mad Libs that we used to do.
Yeah, it does. Absolutely does. All right. So when I post this tomorrow morning, all this code you see here, I'm going to put in the announcements. So you'll have all this code to play with. Okay. And I use the word play, and I mean it that way because one of the best ways, the only way to learn this is start playing with this. Start writing queries. Start like, I wonder if there's any queries that have the word pig in it. Let me find out. Oh, look, a brilliant drama of a pig and a mad scientist who battle a astronaut in Soviet Russia. I don't know, whatever. You'll find probably a film with that, right? But like start playing with these and start writing queries and go beyond the like I said before I came on today, I was writing queries just to see what happened with them. But let's take we got 4 minutes left. We're going to go a little over tonight. I want to talk about how the SQL engine runs the query. And I'm just going to do this real simple one here. Okay, I'm not going to get into inner joins or anything. So you've got 4 key commands here: select from, where, and order by. Which command do you think SQL runs first?
From.
Exactly, it is from. And I'll tell you why. Because you cannot do anything to data that is sitting on a hard drive. The data must be in memory. Okay, so you've got, you got your hard drive on your computer and you've got your RAM on your computer, right? So whenever you run a query, this all happens in RAM. It does not happen on the hard drive. So when you say select far from where, the first thing it says, okay, it needs the customer table. Get the customer table from the hard drive and put it into RAM. So the customer data goes into active memory. The next thing that runs is the where clause. It goes to say, go to last name, give me all the last names that have that D in it. And then it just deletes everything else. And then it says, okay, give me only the columns that they want, a guy wants, and put it in there. And the last one that runs is the order by. Okay. There's a reason why this happens, and that's a 2-hour conversation on how extents and a data store works on a hard drive. But suffice to say, whenever, and this is why it's important to understand data types and everything like that. Whenever you're working with data, that data has to be in active RAM. So if you're pulling in 12 gigabytes of data, you're going to take up and use 12 gigabytes of RAM on that computer. This is why when you look at servers that run databases, you have hundreds of gigabytes of data on them. All right. So just, I mean, this has nothing to do with the class. This is just a quick peek under the covers how this works. So it runs from, it runs where, it runs select, it runs order by. It runs from, it runs, there is nowhere, so it runs group by, it runs select, it runs order by. Okay. Any questions on that? Real simple explanation, quick brief run through for the last 3 minutes. Looks like we will not go over unless there's a lot of questions, and I'm cool with a lot of questions. So does anyone have any questions on what we've talked about tonight? We talked about a lot.
I was wondering about the difference between equals and in when you were using them before. 'Cause
Okay.
it looked like they did mostly the same thing.
So let me go back to here. So equals is can only have one value. Ratings equals G, right? Within, ratings are in, and you can have multiple values in that.
Okay, so you can't say rating equals G and PG or something.
I mean, you could do this. You could do that, but you know, you're, well, that would yield no results, but you could do this. You could
Yes,
do
but
that.
I
Yep.
see now that that's too much work. So
Yeah, you're exactly right. We want to conserve keystrokes. Thank you. Brilliant observation, seriously. The other reason with ins, and we're just as like a preview, guess what you can put in here? You can drop a query into those parentheses. And so in becomes even more valuable. And we will talk about that later. They're doing a cliffhanger, so you're excited for next time. All right. Any other questions? All right, then. Thank you for coming tonight. We had 12 people. Oh, we got a chat question here. From where? Group by having, so yeah. Oh, okay, David, you had to throw the having in there, man. You're doing more work than I am. We haven't even gotten to having yet. Look at you, look at you. Yes, this is the correct. From where, group by, having, select, order by. That is correct. Yep. We'll talk about having in like 3 weeks. I'm tired tonight. We're done. But having has to do with group by.
does this normally start at 7:30 on Wednesdays? Is that the idea?
It starts at 9:30 Eastern time.
Okay, so
So
7:30 my time.
Where you at?
I'm in Utah.
Yeah. Okay. Yeah.
Mountain.
Yeah. So Mountain Time. So 7:30 your time, 6:30 California, 5:30 Africa, and we've got one student in Gabon who it's like 3:30 in the morning here, so he probably won't be showing up. So, if you ever can't be here on a Wednesday night and you have questions, when I put the announcement up for Wednesday, if you put questions in there, I will answer them in video. So you can get those answers. But other than that, so yeah, so 7:30 your time. Yep. There's no one. I tried the first couple semesters I did this to find a good time for everyone to be there, but there's just not. And my day starts at 5 a.m., so I got to get to bed at some reasonable time because seminary here on the mission field starts at 5 a.m. So
yes, it does.
It does. All right. Any other question, friends? All right, if we're good, then thank you for coming tonight. I will see you guys next week. And as always, if you have any questions, comments, or queries, just pop into me in chat. I will answer. Wait, there's chat here. 2:30. Are you in West Africa? Moynihan? God bless you for being up at 2:30 in the morning. I don't know. I could be, yes, I couldn't do that. That's dedication. That's why I record these and post them. So people can't be there, can be here. But thanks for being here at 2:30 in the morning. All right. We're good. I'll see you guys next week.
Thanks, Brother Stevick.
Bye-bye.
Thank you.
Thank you. Bye bye.